Okay, this is video 2 of chapter 1, lesson 5, and in this video we're going to look at absolute value inequalities. We just looked at absolute value equations, and as a quick review, you remember that once we had the absolute value by itself, we got two answers. We took what was inside the absolute value symbols and we set it equal to what's on the right side of the equation or the other side, and then we took what was inside the absolute value and we set it equal to the opposite of what was on the other side of the equation. So when we're going to do these inequalities, we're going to do the exact same thing. Nothing's different. However, we're dealing with greater than or less than signs, and remember, when we have two inequalities, greater than or less than, we have what we call, remember, compound inequalities. So actually, these absolute value inequality expressions are going to produce compound inequalities. And you remember, we have two types. We have ors and we have ands. So which one's going to be which when we're dealing with absolute value? Well, let's take a look. If you have an absolute value that's greater than, or it's greater than or equal to, and you create the two inequalities, you're actually going to end up with an or type inequality and an or type answer. Let me show you why. If we have this expression, the absolute value of x is greater than 4. Remember, absolute value means distance from 0. So if I was to put this on a number line just to get a graphical picture or representation of it, here's 0, here's 4. Now this says, remember, absolute value is distance from 0, so I'm looking for numbers whose distance is more than 4 away from 0. So if I go 4 this way, this is exactly 4 away from 0. What numbers are more than 4 away from 0? Well, those would be the numbers out here. All of these over here are more than 4 away from 0. But remember, we can also go 4 in the negative direction. So if I go 4 over here, I end up here at negative 4. Now, where are the numbers that are more than this 4 away from 0? Well, we'd have to go out this way. These numbers out here are more than that 4 away from 0, and you'll notice that this graph, or this number line representation, looks like an or, because remember, the ors go out this way, and that's what we have. So you can see, if it's greater than or equal to, that's going to produce an or type inequality. All right? So what about less than or equal to? Well, let's go ahead and take a look at this same example, but instead of greater than or less than, let's do, greater than, let's do less than. Okay, so let's say we want the distance to be less than 4 away from 0. So the absolute value, the distance from 0, is less than 4 units away from 0. So here's 0. If I go out here 4, now where are the numbers that are less than that far away from 0? Well, that would be these numbers here. All of these are less than 4 away from 0. And if I go out here to negative 4, if I go 4 units this way, now where are the numbers that are less than that far away from 0? That would be these numbers here. And you'll notice this looks very much like an and inequality, which in fact it is. So these less than absolute value inequalities are actually going to produce and inequalities. Okay? Okay, so let's look at a couple more things about absolute value inequalities. So how are we going to do these? How are they going to look algebraically? So what we're going to do is we're going to isolate the absolute value expression first, just like we did before, and then once we've done that, we're going to go ahead and write the two inequalities. Now there's one thing that's going to happen when you write inequalities that didn't happen when we're writing equations. So let me show you that quickly again on our example over here. So let's say we have the absolute value of x, which I have up here, is less than 4. So you remember, we write our two inequalities. We take what's inside the absolute value, and then we just write it, and then to the positive of what's on the other side. Now, the second inequality comes from doing this. Now, I'm going to take the opposite of 4. Now, you have to remember, it kind of ties into a rule we had before. When you divide by a negative, what do you have to do with that absolute value, or that greater than or less than sign? You have to reverse it. So when I take the opposite when I'm doing the absolute value, I have to take this sign and I have to reverse it to create my two inequalities. Okay, so remember, it's kind of a hidden thing. I hope you got that. So x is greater than 4 and x is less than 4 and x is greater than negative 4. So remember, we said that the less than is going to be an and inequality. So it should look like this when I get done. Okay, so here I have x is less than 4. So that's the x is less than 4, open circle, that's this way. And here x is greater than -4. So here's -4. Where the number is greater, those are here, and sure enough, it looks like an and inequality, like it should. So make sure when you write your inequalities, you reverse this sign when you write the opposite. So when you write the opposite, make sure you reverse the sign. Okay, otherwise you're going to end up with some problems. Okay, so just as a reminder, make sure that when you do these absolute values, you isolate the absolute value expression first. You write the two inequalities, but remember, when you write these two inequalities, make sure you reverse do that. Okay, so let's go ahead and take a look at an example. Let's look at this example right here. So we have a less than or equal to sign, so that tells me it's going to be an and inequality. So my answer should look something like that when I finish, in most cases. So we'll go ahead and solve this exactly like we would an equation. We have to get the absolute value symbol by itself, so I'm going to add 7 to both sides. It's going to give me 16. I'm going to need to divide by 4. Again, I'm trying to get this absolute value by itself, less than 4. Now that I have it by itself, I can go ahead and write my two absolute value expressions. So the first one is 2w plus 3, and I keep the sign and I take the positive of this side. Okay, so it's 2w plus 3 less than 4. It's 2w less than 1, so w is less than 1/2. And then when I do the other side, I'm going to write the second one, 2w plus 3. Now remember, I've got to reverse this sign, so it's going to be greater than. And I'm going to take the opposite of this whole side over here, so I'm going to take the opposite of 4. It says 2w plus 3 is greater than -4. And then 2w is greater than -1, -7. And then w then would be greater than -7/2. So I have my two inequalities. Now I'll go ahead and graph that solution. So because I'm dealing with a fraction here, I need to put the two numbers that it's between. So 7/2 is 3.5. So I'm looking at -3.5. So -3 is here. I say -4 here. So right here I have -7/2. It's greater than. It's not included. Okay, so we're the ones that are greater than that. That's up this way. And then I have w over here less than 1/2. So here's 1/2 would be right here. It's less than or not equal to, so it's here, and less than numbers would be here. So you'll see I end up with an and inequality picture, which is what I should have expected when I had a greater, less than, or equal to sign. Okay, so I have my two inequalities, one here, my other one here, and then I have my graphical representation of that. Okay, so make sure you take a look at that as you do that. All right, I'd like you to look at numbers 22 in your book. So once you stop the video, go ahead and do number 22 and then come back and I'll have it done here. Actually, I'll walk through it with you and then you check your work and then we'll go on from there. Okay, number 22, again, we want to look here before we start. It's a less than, so less thans end up being and inequalities, and so my graph should look something like this when I'm done. In most cases, sometimes we may have something weird going on, but we've talked about that. So let's go ahead and do this one. So we're going to divide by 3 to begin with so that I get the absolute value by itself first. So I have y minus 9 less than 9. Then remember, I'm going to create two inequalities from this. So I have y minus 9 less than the positive of this entire side. So y minus 9 less than 9. So y is less than 18. So there is one of my inequalities. Then I need to go ahead and write the second one. So again, I take what's inside the absolute value. Now remember, I have to reverse the sign because I'm taking the opposite of this whole side. So y minus 9 greater than -9, so y is going to be greater than 0. So there's my second inequality. Then I need to go ahead and graph the solution. or show it on a number line. So here I'll match the colors up for you so you can see. So I have 0, y is less than 18, so 18 is out here, less than, not included, so less thans would be this way. And then my other inequality, I have y greater than 0, so 0 is not included, open circle, greater than goes this way. So if I go up here, all the way here, you can see that my answer looks like what I thought it should because it's a less than. So there's your and compound inequality. All right, so let's go ahead and why don't you guys go ahead and do now number 21 in your book. Again, stop the video, do number 21, then come back, I'll walk you through it, and then we'll wrap this lesson up. Okay, here's number 21. Let's go ahead and step you through it. Now, as I look again at first at the greater than sign, I realize a greater than is going to be an or inequality. So my answer should look something like an or, where the graph goes out either way. So I kind of get a picture of that before I start. So we need to isolate the absolute value. So we're going to go ahead and add 4 to both sides. 3z greater than 12. Then now that we have the absolute value isolated, I can go ahead and write my two absolute values. So I have 3z greater than, and I'm going to take the positive of this whole side. So 3z greater than 12, so z is greater than 4. So there's one of my inequalities. And then I need to go ahead and do the second one, which again, I take what's inside 3z. Remember, we reverse this sign, it goes like this, and we take the opposite of this whole side. That's a 2. 3z less than negative 12, so z is less than negative 4. So I have my two inequalities. I then go ahead and graph the solution, okay, using my number line. So let's say I have 0. So first one, I have z is greater than 4. So here's 4. It's greater than, not including 4. So greater than, the numbers would be out this way. And then when I do the other one, z is less than negative 4. So here's my negative 4. Here's 4. Where are the numbers that are smaller than this one? They go out this way. So there would be my answer. And again, it looks like an OR graph, which I expected because I looked at that beforehand. All right. So make sure you always look at beforehand, get an idea of what your answer should be before you continue, and then you can double check your answers.